I wanted to talk a little bit about the additional problem number 4 from this past problem set. So this one asks you, it's sort of an interesting, very, very context-rich, kind of tricky problem. Dealing with your advisor, asking you if you can put a satellite into orbit around Antarctica. All right. And so I'll admit this is a challenging problem because it requires a lot of visualization. So what I wanted to do here is I wanted to sort of try to present it in a bunch of different ways. Okay. So the first thing that I wanted to do is get you to so on the problem set, I indicated where the South Pole is, and I indicated the orbit. And so what I did here is I went to Google Earth and downloaded. There's a cool plugin, and I wanted to sort of show you roughly where that orbit is. As we look at the globe and as we sort of imagine rotating it so that we're right above the South Pole, which is right about there. Okay, and so if you look at the if you look at the pictures the picture that I put up there, we're sort of zooming in so that when we're right above the South Pole, our orbit is circular and kind of looks like this. Now, the part that I didn't tell you, what Davis Research Station was or where it was. But the idea in the problem is that, well, the satellite has to go over Davis every rotation. So it has to be in orbit, and it has to be in such an orbit that it never really leaves Antarctica. Right? And so you might have been clever about this. You might have looked up Davis Research Center, and I did. And this will probably show up better in the PDF. But Davis Research Station is right there. So this is the Google Map version, okay? And so Davis Research Station, if you kind of imagine going up this way, India's over here, all right? And so Davis and basically the tip of India are at the same longitude, but they're at, of course, different latitudes. And really, this is quite tricky, all right? Because what I'm asking you to visualize is, okay, first of all, the orbit. Well, if we're looking at the Earth, kind of like this. This is our Earth now. The orbit looks something like this. Okay, if this is the South Pole and that's the North Pole, the orbit is kind of like that. All right. So Davis here is about 68 degrees. So again, you'd have to look this up. But it's kind of down here. It's kind of right here. That's where Davis is, and so our orbit has to circle Antarctica, and we have to cross Davis Research Station. And so again, if this is the Earth, then our orbit looks something like, well, if I draw sort of a radius out here, it kind of looks like, sort of exaggerated in space, it kind of looks like that. Okay. But note that we're not crossing the equator, and we're not crossing the other pole. And so that's what makes this problem so difficult, is what I wanted you to do is pull from the context the fact that if this is the Earth, and this is our satellite, our force, our gravitational force, does not point radially inward, so our orbit looks like this. The gravitational force doesn't point radially inward. It actually points towards the center of the Earth. So that's Fg. And while there is a component of that force that points radially inward, namely that thing, so that right there is Fg radial. The difficulty with this problem is that, well, if I break this force down into components, there's a component that points, that way, up in the y direction, that doesn't have a counterforce. So it turns out that, I'm going to write it down, this orbit is not stable. In other words, it's not possible, because I have a net force that not only has a component that's radially inward, it also has one up towards the Earth. So actually, this orbit will decay. So it's not the same kind of an orbit that we saw before. This is also quite a bit different from the problem that we talked about in class, where so if this is the ceiling, we hung from the ceiling a string with a ball on the end, with a mass on the end, and we imagined putting it into that kind of an orbit. In this problem, the tension points upward, but I have gravity acting downward. So there's a balance. So in the y direction, the tension force in the y direction can balance mg, and the tension force in the radial direction can cause a centripetal acceleration. But there's no counter to the component of gravity in our problem pointing upward. So you have to tell your advisor that you can't do this orbit, and that in this case, basic physics has saved you from a tremendous amount of work, because you don't want to submit this proposal, you don't want to do this work because this orbit's not possible. Okay?